So I'm going to do one more example of finding the limits numerically just to kind of get my point across. This time I'm going to use this function here. This is not a piecewise function. This is a nice, pretty rational function. So I'm going to worry about a couple of things. So again, we're going to review some algebra skills, and we're going to plug in these values and see what happens. And then we're going to try to do the same thing with calculus over here, okay? So let's start off by looking at f of 0. Again, this is going to be my y-intercept. All I got to do is plug in 0 and see what happens. So if I plug in 0 up here, we're going to do 0 squared minus 0 minus 6 over 0 squared minus 5 times 0 plus 6. If you notice, these first few terms on top disappear, so do the ones on the bottom. We've got negative 6 over positive 6, which reduces to negative 1. All right, let's try a few more. So f of negative 2, so I'm going to plug in negative 2 and see what happens. So I'm going to do it down here. Negative 2 squared minus negative 2 minus 6 over negative 2 squared minus 5 times negative 2 plus 6. All right, so on the top, we've got negative 2 squared, which is positive 4, minus negative 2 turns into a positive 2, minus 6 over negative 2 squared is positive 4 again. Negative 5 times negative 2 makes a positive 10 plus 6. So on the top, we've got 4 plus 2 minus 6. 4 plus 2 is 6. Minus 6 makes 0. Over 4 plus 10 plus 6 is going to make 20. This is going to reduce down to 0. So that right there, f of negative 2, is actually an x-intercept. We got 0 as our answer. Makes it an x-intercept. All right, I'm going to try the other ones. F of 2, so we're going to plug in 2. All right, I'm going to do it over here. So we're going to do 2 squared minus 2 minus 6 over 2 squared minus 5 times 2 plus 6. 2 squared is 4 minus 2 minus 6 over 2 squared is 4 minus 10 plus 6. 4 minus 2 minus 6 should leave me with negative 4 over 4 minus 10 plus 6. 4 plus 6 makes 10, minus 10 makes 0. Now, hopefully you guys remember you cannot divide by 0, so negative 4 over 0 is undefined. There is no y value there. F of 2 is undefined. Let's try the last one, f of 3, and see what happens. So I'm going to plug in 3. So 3 squared minus 3 minus 6 over 3 squared minus 5 times 3 plus 6. 3 squared is 9 minus 3 minus 6 over 3 squared is 9 minus 15 plus 6. 9 minus 3 minus 6 is 0. 9 minus 15 plus 6 is also 0. Again, you cannot divide by 0, so this one is also undefined. That's the trick. If you get a 0 on the bottom, it's undefined. It is not going to work. So 2 and 3 have to be excluded from my domain. All right, let's flip over and look at the calculus. So even though there is no number that you get out, there is no y value for these x values, I can still see if it approaches a specific y value and see what happens. So here's what I'm going to do. I'm going to try to do these limits, again, numerically, by making a table of values and seeing what happens. So let's try this first one. I'm going to do it kind of up here at the top. So on the first one, I'm going to try to find the limit as x approaches 0. We need to remember to plug in some numbers on the left side and on the right side. So I'm going to plug in some numbers. Let's see. I'm going to do, let's try negative 0.1. Let's try negative 0.01. And let's do one more, negative 0.001. All right, plug in the same numbers, only the positive version because we want to do the right side as well. So I'll do 0.1, 0.01, and 0.001. All right, I'm going to plug in those numbers. I'm going to do it in my calculator so I don't have to think too much about it because, you know, I'd rather much easier to make sure I get the right answer than to stress about, you know, making a small little tiny mistake and you know, everything go awry, not get the answers I'm looking for. So I'm plugging everything in, negative 0.1 squared minus negative 0.1 minus 6 over all that stuff where I plug in negative 0.1 squared times, negative 0.1 squared minus 5 times negative 0.1 plus 6. And in this case, I got Ooh, a really long number. I'm going to try to round it off. So negative 0.904761, and it just keeps on going. So I'll just round it off at negative 0.9. Let's plug in another number and see what happens. I'm going to plug in negative 0.01. I'm just making a couple alterations in my calculator, trying to make it easier on me. So when I plug that into the calculator, again, I'm probably going to end up rounding. Let's see what I get. Negative 0.990049. Yeah, big long thing, but basically really, really small number. So I'm going to go ahead and try to make a few more adjustments and try that last number out, where it's got 2 zeros and a 1. My calculator's being a little slow because it's like these numbers are just crazy. So sorry if it takes me a second to plug them all in. Let's see. And on this one, I get another really, really small number. So negative 0.999 and a bunch of zeros and then some extra stuff at the end. So notice this seems to be approaching negative 0.9, negative 0.99, negative 9, or excuse me, negative 0.999. That seems to be going really, really close to negative 1. Let me try to do the same thing again with the positive side. I'm going to start at the bottom, I guess, and work my way up. So I'm going to start with this really kind of longer number here. The negative positive 0.001. Let's see what happens. So if I plug in the positives, I get negative 1.001. So another really, really number, really, really small number, close to negative 1. Like, I mean, really close. Again, I'm still rounding these off just to try to make my life simple. I don't want to have to write out the entire thing just because, you know, these are really, really long decimal places. So negative 1.01. So I'm trying my last number now, the 0.1. It's positive. I'm just trying to make sure I plug everything in correctly. All right, I got negative 1.105 and a bunch of stuff. So notice this also seems to be approaching negative 1. We've got negative 1.1, negative 1.01, negative 1.001. So I'm pretty happy, pretty safe to say that this is going to be negative 1. So let me go ahead and try the next couple and see what happens. So we're going to try the limit as x approaches negative 2. So let's try plugging in some numbers there. Again, you could be trying this on your own and trying to figure some of these out and seeing what numbers you want to try. By all means, feel free to test more than 3 numbers. It's always a good idea to test more than you have to. More information is always better than less information. So I'm going to try to apply some similar idea here. And let's see, we're going to do, I'm going to do negative, let's see, negative 2.1, let's try a negative 2.01, let's try a negative 2.001. That'll be on the left side of negative 2, and let's try the right side. We'll do, I guess, negative 1.9, we'll do negative 1.99, negative 1.999. Notice I don't have to keep testing the same kind of numbers over and over and over again. I just want to try to test numbers that are going to give me a decent bit of information. Like I said, the more information we have, the happier we are. So I'm going to try plugging these in, negative 2.1. I know I'm definitely going to have to end up rounding again like I did before. We're just going to see what happens. I know this is always the worst part ever, where you're just kind of typing stuff in the calculator and it kind of seems to dull for a second. All right, so on this, I've got 0.02 and some change. Let's try negative 2.01. All right, so on this one, I've got another really, really small number. This time it's got one of those times 10 to the negative 3, or perhaps your calculator might say an E with a negative 3 at the very end. That just means there's extra decimal places at the front. In this case, I'm going to move the decimal place over 2 places, before I get anything. So there's the 1, 2, 3. Again, that's scientific notation. That always comes in handy when you are dealing, especially with rational functions, because things kind of get a little hairy scary in the fraction department. So I'm still plugging in this last number and seeing what happens. Again, I know for a fact it's going to be really, really small. We get ends in a times 10 to the negative 4th. So that means it's going to end up being a 0.1, 2, 3 zeros, and then a 2. So these seem to be getting really, really small, close to 0. All right, let's try plugging in those negative 1.9 kind of things and see what happens. All right, so here's what I'm doing. I'm plugging in the negative 1.9, and then I'll try negative 1.99, and then negative 1.999. I'm going to go ahead and kind of skip ahead and try to write all these numbers down real fast. All right, so I kind of skipped ahead a little bit just to speed up my calculation a little bit. Notice I went ahead and plugged all these numbers in and got these f of x values out. I got negative 0.03 when I plugged in negative 1.9. I got negative 0.003. Again, I'm rounding here. It was actually 2.5, so or excuse me, 2.5 at the end, so I rounded. Negative 0.0003. Again, seem to be getting smaller and smaller as I go, getting closer and closer towards 0. This one happened to be positive values. That one happened to be negative values. So just making sure, again, we're approaching 0. So I'm going to go ahead and try to do these next couple. I'm going to go ahead and write down the values I'm going to test around 2. I'm going to try to test similar values just because it kind of makes my life easier if I don't have to mess around with the numbers too much. But this time, since I'm doing positive, I'm making sure my numbers are positive. Unfortunately, I got this. This is going to be my left side. That's going to be my right side. I know I got them switched on my paper, but it'll be all right. I'm going to kind of skip ahead again and just get these numbers written down, and I'll be back in a second. All right, so I'm back. Like I said, I was just typing everything in the calculator, and when I started typing in this right side, this 2.1, 2.01, 2.001, I started getting bigger and bigger numbers. So it started at 41, went up to 401, then it went up to 4,001. I even tried the next number just to see what was happening, and I got 40,001. So these numbers keep increasing and increasing and increasing, and they don't seem to ever be stopping increasing. They just keep getting bigger and bigger and bigger. I'll use the word unbounded on this. It doesn't seem to be approaching any number. It just keeps going and going and going, and these are positive numbers. When I plugged in 1.9, 1.99, 1.999, I got negative 39, negative 399, negative 3,999. I even plugged in again another one. I plugged in 1.9999, and I got negative 39,999. So these are also unbounded, but these are unbounded toward the negative. So one's going up really, really fast. The other one's going down really, really, really fast. So in this case, they're not approaching any particular number, nor are they going in the same direction. One's going up, one's going down. So this will be a does not exist. Okay? So notice f of 2 was undefined, and the limit was does not exist. Now, that's not going to always be the case, as you're going to see when I go ahead and do the next one. F of 3 was undefined, but I know that I'm getting ready to test it. The limit as x approaches 3 of f of x is defined. Again, I'm going to go ahead and do one more real fast. I'm going to go ahead and do that. I'm going to make the tables. And I'll do it over here. I'm going to, again, skip ahead and do all the calculator stuff. I'll go ahead and write down what I'm going to plug in. I'm trying to approach 3 here, so I'll start at 2.9. I'll do 2.99, and I'll go ahead and do 2.999. On the other side, I'll do 3.1, 3.01, and 3.001. So I'm approaching 3 from the left side, 3 from the right side, and again, skip ahead, and we're going to do all the calculations in the break. All right, I'm back, and so I've done all the calculations. When I plugged in 2.9, I got 5.4 repeating. When I plugged in 2.99, I got 5.04, both of those repeating. When I plugged in 2.999, I got 5.004, all of that repeating. So it seems to be getting smaller and smaller, closer and closer to 5. When I did the 3.1 and 3.01 and 3.001, I got 4.63 with the 63 repeating, 4.9603 with the 9603 repeating, and 4.996003 with all of that repeating. So this seems to be getting closer and closer also to 5. Again, this one's going down to 5, this one's going up to 5, but either way I slice it, they're both going to 5. So notice, again, over here, f of 2 was undefined, the limit as x approaches 2 does not exist, but f of 3 was undefined. In this case, f of x went to 5. So in this case, the limit does exist, where in the other case, it does not exist. So there is not, I'm going to say, a one-size-fits-all rule for every rational function ever. I will say there are going to be some things we talk about later on in the course that will help you kind of discover when this stuff works, when this stuff doesn't work. But for right now, I'm trying to get across how to find limits numerically. So make sure, again, try to work out this stuff. It's mostly calculator work. You should be able to figure it out pretty easily. Make sure, again, read your notes, and I'm always here to answer your questions if you need help. All right, have a good one.